Physics review video, Unit 2, constant velocity, skill, displacement problems. We are going to take a look at just a few example problems. Feel free at any time to pause the video and try the problem on your own first, and then hit play again and see if you got the same answer as I did. Let's start with a school problem. School bus takes 0.530 hours to reach the school from your house. If the average velocity of the bus is 19.0 kilometers per hour to the east, what is the displacement? So let's think about what we know and what we need to know. Displacement we know is delta x in an equation. That's change in position. We know we have a change in time, and this, because I have a magnitude of a rate and a direction, this looks like this is a velocity to me. And it also says average velocity. So there are your clues. I have a v, a delta x, and a delta t. You should recognize from your equation sheet or your notes that we do have this equation. Delta x equals vt. That equation will work. Remember, that is also the same equation as final position equals velocity times time plus initial position. We just subtracted the initial position from both sides to get delta x. So let's plug in what we know. Let's make sure all of our units work. Looks like I have kilometers and hours. That matches up. So I'll put in my time, 0.530 hours. I don't know my velocity, so I'll leave the v variable in. And actually, I don't. I do know my velocity is 19.0 kilometers per hour. I don't know my displacement. Remember that kilometers per hour is to the east. I'm just having to multiply here. 19.0 times 0.530. And it looks like I have a displacement of 10.07. The hours canceled, kilometers, and I need my direction to the east. That would be a full final answer. Let's take a look at another problem. A particle travels from position 6 meters to position 980 meters in 0.75 seconds. What is the average velocity of the particle? Once again, let's read through the problem and figure out what we know. I have a starting position, which some teachers might say xi or xo. I have a final position, x marks the spot, or xf, and it looks like I have a time, and they want a velocity. I have one equation that works. X equals vt plus x naught. Notice, just like in the last problem, that is the same equation as delta x equals vt. Let's plug in what we know. 980 meters equals v, I don't know, 0.75 seconds plus 6.0 meters. Let's do a little algebra. 6.0 meters from both sides. So I get 974 meters equals v times 0.75 seconds. Divide 0.75 seconds. So 974 divided by 0.75, I get 1299. Look at my units now. Meters over seconds. Now notice, they don't give us a direction like north, south, east, west, but we can also signify direction as being positive or negative. This answer came out as positive, so this suffices as an answer. When doesn't it come out as positive? Let's look at example 2 right below. A different particle travels from position 7.5 meters to position negative 145 meters in 0.5 seconds. What's the average velocity of the particle? Once again, let's look. We're looking for velocity. It looks like I have an initial position and a final position and a time. Same equation. Let's plug in I have velocity, I don't know, negative 145 meters. Subtract 7.5 from both sides. Looks like I have negative 152.5 meters equals v times 0.5 seconds. Divide both sides by 0.5 seconds. 152.5 divided by 0.5. My velocity is negative 305 meters over seconds. That negative is your direction. Your magnitude is that 305 meters per second. Magnitude and direction mean I have a vector. Let's take a look at another problem. A horse runs at an average velocity of 25 meters per second for 80 seconds. Assuming the horse runs in one direction, what is the displacement of the horse? Looks like I have a velocity and a time, and I want displacement. Delta x equals vt. Delta x equals 25.0 meters per second times 80.0 seconds. Notice the units, seconds are going to cancel, so we're going to be left with meters, a beautiful unit for displacement. And then you just have to multiply. That should be 2,000 meters. Direction, once again, this is just a positive or negative. We'd assume this is in the positive direction since no other information was given. Remember, you might see the equation written like this: displacement equals velocity times time, or you may see it as final position equals velocity times time plus initial position. Either way, same equation. If they only give you an ending position or displacement, sometimes you can assume this is 0, and you get the same thing.